Horizontal stretches and compressions. Now we consider changes to the inside of a function. When we multiply a function's input by a constant or a positive constant, we get a function whose graph is stretched or compressed horizontally in relation to the graph of the original function. If the constant is between 0 and 1, we get a horizontal stretch, meaning that if it's a fraction or a decimal that's in between 0 and 1. Now, if the constant is greater than 1, we get a horizontal compression of the function. So you can see here the original function is y equals x squared in blue. Okay? So if we take the input and multiply it by a number greater than 1, in green, what it's done is it's compressed horizontally, meaning that it's made it closer to the y-axis, so it's compressing horizontally. Now, if we multiply the input by a number in between 0 and 1, like 0.5, well, you can see that the red gives it a horizontal stretch, so it's making it wider. So, outlining what we saw above, if we're given a function y equals f of x, the form y equals f of b times x results in a horizontal stretch or compression. When we consider the function above, y equals x squared, we saw from the graph that y equals 0.5x squared is a horizontal stretch of the graph of the function y equals x squared by a factor of 0.5. The graph of y equals 2x squared is a horizontal compression of the graph of the function y equals x squared by a factor of 2. So, a horizontal stretch and compression definitions. Given a function f of x, a new function g of x is equal to f of bx, where b is a constant, is a horizontal stretch or horizontal compression of the function f of x. If b is greater than 1, then the graph will be compressed by 1 over b. If b is in between 0 and 1, then the graph will be stretched by 1 over b. If b is less than 0, then there will be a combination of a horizontal stretch or compression with a horizontal reflection.